Hello, I'm Patty Simpson with Simpson Math. Let's find the greatest common factor. First, what does it mean to be a factor? Well, when we multiply two numbers together to find the product, we call the two numbers that we're multiplying together factors. So we take a factor times a factor makes a product. So when we multiply two numbers together, they're called factors. So let's think about all the factors that make up 24. There's lots of numbers that I could multiply together to make 24. I could do 1 and 24, because 1 times 24 makes 24. 2 times 12, 3 times 8, 4 times 6, 5 doesn't go in there, but 6 does. Oh, we found all the factors of 24, all the whole number factors of 24. I mean, we could have factors that were like 48 times 1/2, but these are all the whole number factors of 24. So that's what it means to find a factor. Is just some number that we can multiply by another number that gives us our product. Nice whole number that doesn't have a remainder. So when we're talking about the greatest common factor, we're looking for the biggest number that can go into or is a factor of two different numbers. So for instance, here I found the factors of 24. What if I found the factors of 8. Let's find the factors of 8. Well, the factors of 8, 1 times 8 gives me 8. 2 times 4 gives me 8. 3 doesn't go in there. 4 does. Oh, when I wrap back around like that, I know I found all my whole number factors. So those are all the factors of 8. Now, when I look for the greatest common factor, I'm looking for the biggest number that goes into both of them. So what's the biggest number that goes into 24 that also goes into 8? So if you look at these list of factors, the greatest number that goes into both of them. Well, the biggest number over here is 8. And if I look, and I can see on the list that 8 is also on 24's list. So 8 is the greatest number that goes into both 24 and 8. We call that factor the greatest common factor. It's the biggest one that they have in common. So this would be one way or one method for finding the greatest common factor. Is just list all the different factors that are in both numbers and then look for the biggest one that's in both of them. I'm going to show you another method for finding the greatest common factor. Another way to do it is to take the two numbers and look for any factor that they have in common. So 24 and 8, maybe you notice right away that 8 goes into both of them, but maybe you don't. Maybe you just notice that they're both even. And so you say, hey, 2 goes into both of those numbers. Well, we can take and we can divide them both by 2 and see what we get. So if I divide 24 by 2, I get 12. And if I divide 8 by 2, I get 4. Notice that 2 times 12, those are both factors of 24. And 2 and 4 are factors of 8. I'm going to do that again. Is there another factor that goes into both 12 and 4? Well, again, they're both even. So since they're both even, I know that 2 goes into both of those numbers. So 2 goes into 12 6 times. So 6 and 2 are factors of 12. 2 goes into 4 2 times. I'm going to look again to see if they have anything in common. And 6 and 2 do have 2 in common. Again, they're still even. So again, I could divide by 2. 2 goes into 6 3 times. So 2 and 3 are factors of 12. 3 is also a factor of 24, 6 is a factor of 24, 12 is a factor of 24. Those are all factors of 24. 2 goes into 2 one time. Now, when I look, this 3 and this 1 don't have anything in common except for 1. It's the only factor they have in common. So I'm going to stop there. Then, because I'm looking for the greatest common factor, I'm going to look at these factors that we found, and I'm going to circle them and make a big G for greatest common factor. And because factors multiply together, I'm going to multiply these numbers. So 2 times 2 is 4, times 2 is 8. 8 is the greatest number that will go into 24 and 8. We saw that here, that 8 is the biggest or the greatest common factor of 24 and 8. Let's practice this some more. Let's practice finding the greatest common factor. Let's find it of 6 and 8. So we just look to see what's a number that goes into 6 and 8. What's a factor of 6 and 8? Well, 2 goes into both of them. They're both even, so I know 2 goes in there. I'm going to divide both of them by 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. Notice that 2 times 3 makes 6, and 2 times 4 makes 8. I look at 3 and 4, and they don't have a common factor. There's nothing that goes into 3 that also goes into 4. We say that these two numbers are relatively prime. So the only number that went into both of them was 2. 2 is our greatest common factor. It's the only one they have, so 2 is the number that goes into both of those. Let's look at 7 and 14. Well, the only number that goes into 7 and into 14 is 7 itself. So 7 divided into 7 goes one time. 7 times 1, 7 and 1 are both factors of 7. 7 goes into 14 2 times. 7 and 2 are factors of 14. These two numbers don't have anything else in common except for 1. So 7 is the greatest number that will go into both 7 and 14. It's the greatest common factor. Let's try 24 and 52. Well, because 24 and 52 are both even, I know 2 will go into both of those numbers. So I'm going to start with the number 2. 2 goes into 24. Well, 2 goes into 2 one time. 2 goes into 4 2 times. 2 times 12 gives me 24. 2 goes into 52. Well, 2 goes into 5 2 times with 1 left over. 2 goes into 12 6 times. So 2 times 26 is 52. I'm going to do that again. Both of these numbers are both still even, so I know 2 goes in there again. So I'm going to divide both of them, or factor both of them by 2. 2 goes into 12 6 times. 2 times 6 is 12. 2 goes into 26. Well, 2 goes in there one time. 2 goes into 6 3 times. 2 times 13 is 26. Now, 6 and 13 do not have anything in common. 6 is even, but 13 is not, so 2 won't go in there. 3 goes into 6, but 3 doesn't go into 13. In fact, 13 is prime. So the only numbers that go into 13 are 1 and 13. So these two numbers are relatively prime, so we can stop. So we know that this 2 and 2 are the only factors that are going to go in there. Because they're factors, we're going to multiply them together. 2 times 2 is 4. So our greatest common factor is 4. Notice that 4 times 6 gives me 24. And 4 times 13 gives me 52. So this is the largest number that will go into both 24 and 52. Let's do one more with 3 numbers. Again, I'm just looking for a number that will go into all 3 numbers. So they're all 3 even, So I'm going to do 2 again. 2 goes into all 3 numbers. 2 goes into 6 3 times. 2 goes into 8 4 times. And 2 goes into 36. Well, 2 goes into 3 1 time with 1 left over. 2 goes into 16 8 times. Now I'm looking for a number that goes into all 3 of them. I see that both of these are even, so 2 could go into those 2, but it can't go into this. I see that 3 goes into 3 and 18, but it doesn't go into 4. So there's not a number that goes into all 3 of them. So if I'm looking at all 3 numbers, 2 is the greatest common factor for all 3 of those numbers. So the way we find the greatest common factor is just start with some number that you know goes in and keep dividing until you run out of numbers. And then once you have those factors, you can just multiply them together, and that'll give you your greatest common factor. Let's do this some more, but let's introduce some variables. Okay, we're going to find the greatest common factor with these terms that have variables. It's the same as what we were doing before, where we look for any number that goes into or is a factor of both of our numbers. So here, when I look at this, I'm thinking of what's a number that's in both of them. We'll notice that there's an x in here and an x in there. So I'm going to factor out, or I'm going to divide both of these by x. Now remember from when we did our exponents, if I have x squared divided by x, that what this is equal to is x times x over x. So I've divided out one x, and it just leaves me with an x. And if I take xy and I divide it by x, again, I'm dividing out that x, it just leaves me with y. So x times x gives me x squared, and x times y gives me xy. My greatest common factor then is x. This is the biggest number that is in both x squared and xy. X times x gives me x squared, and x times y gives me xy. It's the biggest number that's in both of them. Let's try this one. If we look at these, we say they both have an x as well. So we can divide them both by an x. Let's start by dividing them both by x. That leaves me, if I do that division of 3xy over x, that leaves me with 3y. 3y times x gives me 3xy. Here I have 6x squared y. That x squared means 6xxy. If I divide this by x, one of those makes 1, and so it leaves me with 6xy. I'm going to look for anything else they have in common. I notice that they both have a y in common, so I could factor out that y. If I divide this by y now, then that y's would cancel, and it just leaves me with 3. And if I divide this one by y, the y's would cancel, and it leaves me with 6x. So y times 3 gives me 3y. Y times 6x gives me 6xy. Xy times 3 gives me 3xy, and x times y times 6x gives me 6x squared y. I look for anything else these two have in common. Look at the coefficients here, those numbers. 3 goes into 3, and 3 goes into 6. So 3 is a common factor of both of those. So I could divide both of these by 3 as well. 3 goes into 3 one time. 3 goes into 6x 2x times. Now, there's no other factor that's going to go into both of those. So this is going to be my greatest common factor. I just take and multiply those together. So my greatest common factor is 3xy. 3xy times 1 gives me 3xy. 3xy times 2x would give me 6x squared y. So this is a factor and that is a factor of 3xy, and this is a factor and that is a factor of 6x squared y. Hopefully we begin to get a little better at this, and we don't have to go through the process of just doing one factor at a time. Our goal is to get to the point where we see bigger factors all at once. So for instance, I notice in this one that a 2 goes into all of those numbers. So I'm going to go ahead and write down that 2. But I'll also notice that all three of them have an x in them. So I know if x is a factor of them as well. So if I can see a bigger number that is a factor of all of them, I can go ahead and use that bigger number to divide by to begin with. So 4 divided by 2 is 2, and x cubed divided by x is x squared. 18 divided by 2 is 9, and x squared divided by x is x. 6 divided by 2 is 3, and x divided by x is just 1. I look to see if they have something in common. And while these two have x's, that one doesn't. And while these two, 3 goes into them, 3 does not go into that. So there's nothing else that they all have in common. So my greatest common factor this time was that 2x. I found the greatest one to begin with. And 2x times is a factor times the factor of 2x squared gives me that 4x cubed. So I can multiply these together to get my original product. One last one that's a little bit interesting. Here I have 8 times 2x plus 3. And this one I have y times 2x plus 3. Do you notice that in both of them there's a factor of 2x plus 3? This is multiplying times that. So this is a factor and that's a factor. This is a factor and that's a factor. They both have 2x plus 3 as a factor. So I'm going to divide by that 2x plus 3. And here it's going to leave me with 8. And there it's going to leave me with y. But my greatest common factor then is that 2x plus 3. So our greatest common factor is just the number, the biggest number that goes into or is a factor of our numbers that we're looking at. Okay, now we're going to use our greatest common factor to factor a trinomial or a binomial, a polynomial. And so the first thing we do when we're factoring, we're looking for two numbers that multiply together to make our original product. So we're given the product and we're going to break it up into two factors. And we're going to do that by finding the greatest common factor. So the biggest number that goes into every single term. So if I look at these three terms, I notice that in all three of them, a 9 goes into all three of those numbers. So 9 is my greatest number or coefficient that's going to go into all three of those numbers. Then I'll also notice that all three of them have an x. So I can divide out or factor out an x from all three of those as well. Now, when I divide out that 9x, that's our greatest common factor, our biggest number from all of them. Then it leaves me, well, 9 divided by 9 is 1. X cubed divided by x leaves me with x squared. Then I'm going to leave my plus sign. 27 divided by 9 is 3. And x squared divided by x is just x. Then my plus sign comes down. 54 divided by 9 is 6. X divided by x is 1, so I can, 1 times 6 is just 6. I look inside to make sure I haven't missed a factor. So they don't all have x's. 3 goes into those two, but not this one. So that's as far down as I can factor it. 9x really was my greatest common factor. And I have factored this polynomial. I have a number here times a number there. So this is a factor and that is a factor. I factored that. I could check myself by multiplying them out and make sure I really do get this product. 9x times x squared is 9x cubed. 9x times 3x is 27x squared. And 9x times 6 is 54x. So it does multiply back out to that. I'm going to do the same thing here. We're going to factor this by using the greatest common factor. New step, anytime we have a leading negative, in other words, our first number here is negative, we're going to factor out that negative. So our greatest common factor will have a negative on it. So anytime it's a leading negative, we're going to start by factoring out that negative. Then I'm going to look for the biggest number that goes into both of them. Well, I notice they both have a 3, and they both have an A. So 3A looks to me to be the greatest common factor in both of them. Now, I need to look for my other factor. What am I multiplying by that's going to give me back to my product? So I do this division. Negative 3 divided by negative 3 is a positive 1. A squared divided by A is just A. A positive 3 divided by a negative 3 makes that a negative, and then negative 1, and A divided by A is 1. So I need to put the number that I'm multiplying by to get that. And I was multiplying by a negative 1. So this had 2 terms in it. Inside my parentheses needs to have 2 terms in it so I can get back to that product. Then I can check and do this multiplication to make sure I really get back to that product. Negative 3a times a gives me a negative 3a squared. Negative 3a times a negative 1 gives me a positive 3a. So when I multiply that back out, I really do get back to that product. We factor that using the greatest common factor. Let's try this one. We look first for the biggest number that goes into both of them. Well, 9 goes into both of them. I notice they both have an A and they both have a B. Now I just have to figure out what I multiply by to get back to my product. Well, 9 divided by 9 is 1. A squared divided by A is A. B squared divided by B is B. Negative 36 divided by a positive 9 is still a negative. It's a negative 4. And then A divided by A is 1. B divided by B is 1. 1 times 4 is 4. So I have factored this into 2 different factors, 9AB times AB minus 4. I can check myself. 9AB times AB gives me 9A squared B squared. 9 times a negative 4 is a negative 36 with the AB, so it does multiply back out. We factored that using the greatest common factor. Let's try this one. We're going to factor this one using our greatest common factor. I notice that it has a leading negative. Since it has a leading negative, I know that negative needs to come out. Then I look for a number that goes into all three of those. Well, 4 goes into all three of those numbers. And then they all have p's. How many p's can we take? This one has 6. That one only has 5. So the most it can give is 5. And the most that one can do is 2. So the greatest factor here is p squared. So p squared is the biggest number of 2's that I can take out of 1. And now I'm going to divide that or find the other factor. This is one factor, negative 4p squared. So to find the other factor, negative 8 divided by negative 4 is a 2. P to the 6th divided by p squared. Remember what that p to the 6th over p squared is. We can subtract those exponents. 6 minus 2, which gives me p to the 4th. Positive 12 divided by negative 4 gives me a negative 3. P to the 5th divided by p squared. Again, what we're really doing is subtracting those exponents. So 5 minus 2 gives me 3. A negative 4 divided by a negative 4 is just 1, as is p squared divided by p squared. It's a positive 1. That 1 is really important in there, because when I multiply this out, I need to have a number over there to multiply by. If I don't have a number in there, if I don't have another one in there, when I multiply that out, I'm only going to end up with a product with 2 terms. So I need that positive 1 in there so that I can get back to my original product. So make sure that if you have 3 terms in your product, that you have 3 terms inside your second factor. Let's just do a couple more that are a little bit trickier. Here's one, x times 3x plus 4 plus 7 times 3x plus 4. So first, we're going to look for our greatest common factor. So I'm looking at this one, and I'm looking at that one, and I want to see what's in both of them. Well, I notice there's a 3x plus 4 here, and there's a 3x plus 4 there. I can factor out that 3x plus 4, or I can, just like I did with the 9x here, or the negative 3a there, I'm going to put that out front. 3x plus 4. And then that leaves me with, well, if I divide this by 3x plus 4, it just leaves me with x. And if I divide this one with 3x plus 4, it leaves me the 7. So in this case, my greatest common factor was 3x plus 4. I can take that out of both of them, and it leaves me with x plus 7. Let's try one more. Let's do 16x to the 4th y squared minus 24x squared y squared minus 8xy squared. Okay, we want to look for the greatest common factor, the biggest number that goes into both of them. First, I'm going to look at my numbers, my coefficients, and I notice that 8 can go into all 3 of those numbers. So I'm going to start by taking out an 8, or dividing out that 8, factoring out an 8. And then I look at my x's, and this one could give 4, but that one only has 2, and this one only has 1. So the biggest number of x's that can be divided by is just 1. Then I look at my y's, and all of them have a y squared. So I can take out a y squared out of all of them. Now, that's one factor. I need to multiply that times my greatest common factor there, and I'm gonna multiply that by this factor. So 16 divided by 8 is 2. X to the 4th divided by x is x to the 3rd. Y squared divided by y squared is 1. Negative 24 divided by 8 is negative 3. X squared divided by x is x. Y squared divided by y squared is 1. Negative 8 divided by 8 is a negative 1. X divided by x is 1. Y squared divided by y squared is 1. So now I have factored my product here with the greatest common factor. I could check myself by multiplying it back out to make sure that I get my original. So we're going to be factoring here for a while, and always our first step with factoring is going to be to look for a greatest common factor first. And we'll factor by the greatest common factor first thing. Math Made Simple is some math. Thanks for watching.